Okay, so thank you for your session today and for this opportunity. This is Mahmoud. I am founder and CEO of Division X. I have 8 years experience in building machine vision systems, especially with AI for industrial sector, especially for quality inspection use cases. Recently, we started Division X in 2016, building AI machine vision systems. And now I will go through what is machine vision systems and also quality inspection, but with industrial use cases, going to no code AutoML system and what we have in our new tool. It's called TUBA. So let's start. I will start now with what is machine vision systems and what's the difference between machine vision and the computer vision. If you think computer vision is only the the code or what you build based on software to make analysis or make some getting some data from video or images. But when we think in building a machine vision system, it's about building the whole system, including hardware parts. So how you get the images, or how to feed the system with images, how to capture the images and lighting effect, and the processing part, and also the moving parts. So if we imagine this design on the screen, you will find something like a sheet. Can be textile, plastic, metals, any type of sheets. We have cameras here. We have something of related to lighting. Lighting may be under it or above it. It can include different types of cameras, like normal visual cameras, infrared cameras, and the other cameras. All of this type of hardware sets affects on what you build encoding. So when you have, for example, some cases, we need, if we have metal sheets, so we need to use infrared cameras to avoid reflection, as example. So it will affect on what you are write in the codec. So when we need to call a machine vision, it's about building the whole system, building the all hardware sets suitable for the use case, and also building the coding type that may be classic computer vision coding or AI based, is suitable for this case and for this types of imaging feeding. So when we go in the problem itself or the challenges that we face, like human inspectors in manufacturing entities with their eyes, lead to low accuracy and high cost in operation, especially high cost of human inspectors, especially in some niche sectors, leading to missed standards revolt and also unused large volume of data. So what we need to do here is to build automate the quality inspection systems by using cameras and other software behind the cameras. So we automating the inspection process itself. We have real-time data management with standard data sizes or databases or reports and something like that, and also adding AI and deep learning with increased accuracy itself, in addition to make the systems more flexible to work on different types of product in the same time. So it is some of operations that we can do in this idea. So we can verification, classification, problems, identification. Part of it are gouging, especially for 3D imaging, inspection, and also counting. This is some examples of what operation can be done and or what's the problem cases can be solved. When we go here, so we have a traditional machine vision system written by traditional coding systems like image capturing, something like feature extraction, and also make decisions based on this extraction. This is the classic pipeline that can be done. But when you go to AI based, so just train the model with the images. So we need the volume of images to train these models, and also make some prediction and results for this. And building two types of systems, so we mix it between them or have this only. This is the effect having on how to build a machine vision system. And especially for this, you can consider this samples of leather or textile. So we have different type of problems. So we can classify images between good and other defects. Then we can detection where is the defect in each image, and also we can segment the defect from the background. All this operation needed to be done in any quality inspection system. We can do one or do all to have different types of quality inspection skills. So we can only classify between good and bad. We can or we need to define which is the defect itself, and also which is it's based in the image that can reflect it after that in the whole sheet or object, and segment it or separate it from the background. So why we need to automate the quality inspection process? So it's lead to high quality, so need to high prices. This is from business value of it in the manufacturing sector. Lead to a big volume of data that can be reflected to helpful insights and increase ROI. Better quality is in strength the brand itself, and also different qualities standard or different prices or different classes of the products. So we'll go there in some use cases from some sectors. For example, we'll go to the food and beverage sector. And here we can talk about caps and bottle caps. It can be to test the sealing of caps. It's made with infrared imaging. Some examples of sorting, for example, bread sorting here. And sorting is very good application, especially for fresh food, for fresh vegetables and fruits sorting. The fresh food that you buy in your market, it can be sorted with colors, sizes, and also out scratches or out defects. Also, we can read something like expiry date and is any other printing material here. Then we'll go through to pharmaceutical. The famous application in pharmaceutical is about track and trace, to track and trace the medicine packages itself through this barcode and any other text written with this QR or barcode. Inline printing inspection, artwork inspection, artwork or the whole the packages itself, packaging, and also verifying the bottles and what is contained. In automotive, as examples, welding inspection, especially X-ray images of welding inspection, maybe have the gouging to volume check of the cylinders, power steering assembly, and the coating inspection. In coating, we can use sometimes visual to inspect the visual parts, and also it can be infrared too. Stamping and the body parts reading, something like that. In electronics too, it is famous application like PCB quality inspection, soldering inspection, and the component placing on the PCBs, and wafer inspection too. Other applications in plastic like gouging and the plastic sheets inspection, something like that. It can be infrared, also can be by visual too, and BBT code data confirmation. It is a use case, a real use case from Midwest Plastic in USA. They have they will have a problem to make the inspection process. So every time operator stops the line and they take a sample to make some inspection, so they wanted to replace this process by automated process on the whole time. So they use a line scan camera with LED line scan lightning and industrial BBC to automate the whole process. So after 6 months of using this system paid for itself as a ROI, and also reducing the production material waste that represents 60% of the cost. So this is the real business value of using this type of automating the quality inspection system based on machine vision and AI. Okay, what's after else in this point? We have some use cases or some examples from big corporates like GM and B&G that already have a built-in machine vision system in the whole production line in this system. So, for example, in General Motors, they have 2,000 plus smart cameras that have 2 million plus inspection per day and have 1 million plus data sets uploaded daily. There's a big volume of data. It's need a new thinking and a new approach of using this type of data. So they need to automate the image analysis itself, and also what about deep learning on distributed system that they want. On the other hand, in B&G, they have multiple and different types of products worldwide. So they need a simple systems to be simple as using mobile apps on smartphones, and also something to reconfigure and re-engineer to use it on different types of product and data. And the flexibility that avoids them to approaching technology provider to make it for each product. So this is the reason that we built TUBA. It's about no code techniques and also AutoML together to enable the manufacturing sector to build their own AI machine vision systems or computer vision apps by themselves without any coding or AI experience. So we'll go to the traditional machine vision workflow here. Anyone, I think you are maybe aware of this. So the developer go through this process to generate the model to use it. But in AutoML workflow, just feeding the system with the data or images in our cases, and then make the prediction, and go as a no-code interfaces to avoid all this parts. So this how it works. It's about feeding system by images, make the labeling bot, and make the training bot that including different types of operations like classification, detection, and segmentation. Then generate dashboards for prediction or testing, and also can export different types of models, and also generate APIs. These models can be now there's for example there's a deep learning based cameras, the cameras including GPU or FPGAs that can only put your model on it and just run the system. So we reach now to a seamless end-to-end system that the user can use it. Just feed the image and then generate the model. So it's something like building the model on TUBA, integration with deep learning based cameras, and also integration with software or apps or solution according to deployed models or API, already made APIs. So after the whole of that, why we need to use TUBA, or why we need to use no code or AutoML tools? So we have different types of deployment options: the AutoML end-to-end solution and the no code on cloud and on-premise solution, and also your team will make it by yourself. So we'll go here in the build versus buy. Why the manufacturing sectors now need to build their own systems instead of buy a ready-made solution. It's about design the system by themselves, as the expert in the field is the most one near how to solve it. Simplify the setup, greater control, and the most famous area is about reconfiguration and re-engineering the systems to be or to work on different types of products, and integratable bots that you can generate models that can both on cloud and also both on the edge according to the needs of it. Okay, thank you. I finished my presentation now. Any questions?
That was quite fast. Yeah. So I just want to remind that if you want to ask any question, there is a link in YouTube chat that you can just go and ask. Yeah, do you maybe have some sort of demo, like how it looks like, what, um, like how people can use this tool to simplify all this process?
Okay. Maybe I don't have screens for it,
Mm-hmm.
but I
But how does
can.
it look?
Yeah, I can explain it here. Yeah, in this one.
Mm-hmm.
For example, if you have, I will give a real example. Um, uh, um, we have a use case in with X-ray images of metal tubes. So we have a good images and the bad images, and all of them together. So first step two, we need to feed the image to the system. So you upload these images and then go to the labeling process, put the labels, and generate the label data set. All of this coming through interfaces. Then you will choose the training type. You need to make classification or detection or segmentation based on your labeling part. There's some configuration here made in training. Then start your training. The system will make a different types. It is a concept of AutoML, make a different types of models, and then choose the best one of them. Then after the system automatically finishes the training, he will notify you to start the next step. It's about testing. The model will be deployed on the system, and you can feed the model with images to make some tests if it's okay for you. So it is done. So you can generate the model. You can export it as I think the example was on exporting. So you can get it with TensorFlow based or other types of extension. Then you take the model, put it on the camera or put it on Judson board, for example, or put it in your application itself. This is other part. Or you can test it using API. So you can take the link and open your application and feed the system with images. So we from this we have the whole process. The user can go into interfaces to show it or to make it by themselves, then generate this. From here, you can consider that it is helps the user to accelerate the prototyping process as a first part, and then they can use the same system to build the final model that can be used on the final system or on production.
Okay, that simplifies the process a lot, and it can be used for most of the cases you showed, like basically when we have like this production line,
Mhm.
we in all these cases we can use this, right, for automating our
Yes,
decisions.
it can be used for most of quality inspection cases. That's depending on 2D images. Even if images is visual or infrared,
Mhm.
it is the same. Just collecting the images and feeding the system and generating the model by it.
Mhm. So basically, let's say I remember one of the examples was about bread. So I assume that there is some line with bread, and then so basically you take pictures of bread.
Yes.
Yeah, here this one. So you take like as bread goes on the line. So there is a thing that takes pictures at certain interval, right? I don't know, every minute or something like that, right? And then you basically put these um, to this model, and then the model detects the defects, right?
Yes, the effects, and then the camera or the system can generate control signal. This signal
Mhm.
can control the line itself
Okay.
to filter the good bread from the bad bread.
Mhm. Okay. So like the moment it detects bad bread, so what happens? Like there is a alarm and then alert, and then people come and take the bread away, or how does
It,
it work?
it's possible, but it is now it is not the fully automated. So the fully automated system that after there's other mechanical part. So after the camera detect or the system detect that we have here a bad bread, so there's a mechanical system that filter it, reject or going to the good one. So it is going sorting,
Mhm.
filtering them separately, automatically, and it is going to a very high speed. It's not old one. So for these cases, we have some cameras with a very high rate frame per second, maybe reach to 300 or more than that. And for these cases, we need to have a very high processing units, especially embedded one, to have this speed in response.
And I'm just curious, like about the infrastructure. So these things, like, do you do on-device computation, or you send the pictures to the cloud somewhere for scoring?
No, I think it make online
Mhm.
is AI on the edge
Mhm.
to avoid any problem in the
Mhm.
internet connections and the cloud systems,
Yeah, okay.
and to make it very quick as we can, to avoid any delay in
Mhm.
the response.
Okay, makes sense. And you mentioned you use TensorFlow, so I assume you use TensorFlow Lite for that to do this on devices, right?
Yeah, some vector fluid and some for maybe for JSON boards
Mhm.
from NVIDIA. Yeah.
Okay, okay. We have a question. Is the uh, cl defect classification performance better than that of a human?
Uh, yes, and according to the case,
Mhm.
um, which I mean that when we have a constant human factor error. It's constant according to the human, depending on it. So in these systems, the human factor error is zero. So we avoid all of this. But maybe we in some cases, in some special cases, the human existing is more important than systems. Maybe it is in some cases. So the AI systems try now to learn from the human. So if we have expert in making an inspection for metal tubes of its X-ray output, now we can use this human experience to learn the system how he will take the images and make the labeling of it, and then will feed and train the models, and he by self he will evaluate the model performance if it's going well or not. And for this reason, we choose to have enabling approach for the manufacturing sector instead of building the whole solution for them, to help them to solve the very special problems.
Okay, makes sense. Is there any legal accountability for misclassified samples if defects can lead to safety problems?
Safety
Like,
problems, like what?
legal like in the sense that, let's say, like the system misclassified something, uh, right? So it says, okay, this is safe, but it's not, and a spoiled bread goes to production, like to people. Um, do you uh, do you, can you have any legal problems, legal accountability because of that?
um, for all cases that as we have before, we didn't face something like that, as we are working for corporates to improve their quality, to improve their existing and the reputation in the market, and not for legal reason. But we found some others, especially in some sectors like pharmaceutical. They may use some inspection systems to, for example, to make some metal detector. As For example, I found a case with a client that they have some metals particles, small metal particles in the pills. So need something to make metal inspection. This coming from the government, that the government make enforce the whole companies to have inspection, automated meta inspection process on their production line. It's something like that. So I think the legal point is going to the sensitive industries, especially in pharmaceutical one.
Mhm. Yeah, makes sense. Thank you. Yeah, so We don't have any more questions, but yeah, so now is the best time to ask a question. Uh, and there is a short delay between the time we talk and the stream on YouTube, like 10, 15 seconds.
Mhm.
So let's wait for a bit of time, and unless there are no questions, then yeah, maybe in the meantime, can you tell us how we can find you?
Yes, you can send me by email. It is
Mm-hmm.
here. And also you can find me on LinkedIn. Yeah.
Okay. And on Data Talks Club as well.
Yes.
Okay, it seems we do not have any more questions, but if you have any questions at a later point of time, or maybe you watch it as a YouTube video later, these are the contact details. And thanks a lot for coming and sharing this. So I imagine that this is not an easy project to do, like